Huh? And guess what? Who are you gonna see? Nope. She's in. She's out of the Okay, folks, let's go ahead and get started. Where we're going to begin today is we're going to start learning how to write the names and formulas for ionic compounds. We will continue this process into Wednesday. On Friday, we are going to start learning to make covalent molecules, which we will continue on Monday of next week. Before finishing up with acids on the following Wednesday. Now, once we complete learning how to make different types of compounds and how to write the formulas of different types of compounds, then we will go back, we will return back to the mathematics. And we will be doing mathematics for the most part for the remainder of the semester. The first thing that we are going to do mathematically, after we learn how to name all these compounds, is we are going to learn how to develop the molar mass of compounds. Once we learn how to develop the molar mass of the compound, the next thing we are going to be doing is we are going to start reacting these compounds, and we are going to start by balancing the chemical equation of associated compounds. And then we're going to get into stoichiometry. That is where the stoichiometry is where we're going to spend the majority of, besides naming, that is where we're going to spend the majority of the rest of our time in this course. So before I even begin with the information from today, I'm going to see what you, I'm going to try to jog your memory from the Wednesday before fall break. If I asked you what charge this group has, you would say +1. If I ask you what charge group 2 has, +2. If I ask you what charge silver has, +1. How about zinc and cadmium? +2. And how about aluminum, gallium, and indium? +3. How about all the other metals? You gotta have Roman numerals. That's extremely important when we start getting into naming these compounds. If we're talking about the anions of the elements, what will nitrogen, phosphorus, and arsenic have as a charge as an anion? Those are your group 15 nonmetals and metalloids. -3. What would oxygen, sulfur, selenium, and tellurium, which is group 16, nonmetals and metalloids have? -2. And how about your halogens? -1. Your polyatomic ions, as a reminder, a polyatomic ion, if you say sulfate, it always has the exact same atomic composition of 1 sulfur and 4 oxidants, and it always carries a -2 charge. So when we start talking about the polyatomics, their formula, their charge, their name, those are set in stone. That information is going to be vital that you know, because we are then going to learn to develop formulas of ionic compounds from those ions that we have been discussing. When we do so, we're going to make a compound that is charge neutral, meaning that the positive charges of the cations and the negative charges of the anions add up to equal 0. Again, ionic compounds must be charge neutral, where the positive charges of the cations and the negative charges of the anions add up to be equal to 0. When we write the formula of an ionic compound, when we write the name of an ionic compound, the cation, the positively charged ion, is always listed first. Now, we're going to find that the simplest way to think about it is to cross, drop, and simplify. Now, I'm going to give you 2 things. Number 1, when I start getting into these formations of these ionic compound formulas from the ions, one of the things I'm going to do is I'm going to illustrate it, and I'm going to expand on what's going on. But then I'm also going to teach you the simple way, which is to cross, drop, and simplify. And I'll explain that as we go along. We're going to develop the names of ionic compounds from the ions. Again, the cation must always be listed first. And the way we develop the names of the ionic compounds is we write the name of the cation and follow it with the name of the anion. After we do some work with the ions, then we're going to get into the real work, where we start discussing the development of the formula of an ionic compound from the name. When we start developing the formula of an ionic compound from the name, the cross, drop, simplify is the same. The only difference is you've got to add one more step, and that is to translate. And then finally, we are going to start the discussion for developing the name of ionic compounds from the formulas. These last 2 these last 2 numerical points are going to be the things that we're going to focus the majority of our attention on Wednesday. Okay. So if I say I'm going to combine sodium ion with oxide ion, the first thing I note is I look at the sodium. And I'm going, okay, so what charge does the sodium possess? Well, you look at the periodic table. And what charge does a sodium possess? +1, because it is in group 1. So that is Na+. The next thing I note is this IDE. And what did I say IDE always tells you? It's a negative charge, but what else? Anion of
It's an anion of an element. IDE means that the anion is of an element. There are only 3 exceptions to that rule. But the majority of the time, if you see IDE, that means you're talking about an anion of the element. So we are talking about the anion of oxygen. And what charge does oxygen have as an anion? Has a -2. We do tend to write the numerical. Now, it's not going to really matter for this class, but for classes moving forward, when we write charges, we tend to write the numerical value first, followed by the sign. That is so that we can distinguish it from oxidation numbers, which we write the reverse direction. So it's not going to matter much in this class, but it could matter in future classes, the direction you write your charge. Now, if I look at this, I currently have a +1, and I currently have a -2. And if you'll recall, the first thing I said is that they have to be charge neutral. So the question is, does that equal 0? No. Which one is in the lowest supply, the positive or the negative? Which one has the lowest numbers added together? The positive. So we need to add another sodium to this. When we add another sodium, we now have a +2 and we have a -2. And again, the question is, does that equal 0? Yes. So the formula for sodium and oxide is going to take 2 sodiums, which we write as a subscript, and 1 oxygen. And if it's just 1, we don't illustrate it. So the formula of a compound that contains sodium ion and oxide ion is Na_2O. It literally is telling me there are 2 sodiums and 1 oxygen in that formula. Now, to name this, we're going to name the cation first, followed by the anion. And basically, all we do is we get rid of the words ions and we cram the other 2 together. So this is sodium oxide. Let's look at another example. Let's combine chromium-6 with sulfate. Chromium is Cr. And because chromium is not in group 1, it's not in group 2, it's not silver, it's not zinc or cadmium, and it's not aluminum, gallium, or indium, that means it needed a Roman numeral. And what does the Roman numeral tell me? The charge. So on chromium, we're talking about a 6+ charge. Now, the next thing I note is 8. What does ATE tell me? It's a negatively charged polyatomic anion. ATE means it's a polyatomic. So it's one you just have to know. It's going to be, first of all, let's derive it though. Let's derive it from the rules. Sulfate starts with sulfur. Sulfur is in period 3 through 7. So how many oxygens will the 8 have? 4 oxygens. Now, sulfur is in period 3 through 7. So what can we say about the charge on the sulfur? Or the charge about the sulfate, I should say. It's a -2. Why was the charge on the sulfate a -2? Because it's in group 6, because sulfur is in group 16 and sulfide is a -2, so sulfate is a -2. So we have +6, we have -2. Does that equal 0? No. Which one's in the lowest supply, the cation or the anion? As far as the charges adding up. The anion. So let's add another anion. When we add another anion, it's a +6 -4. Does that equal 0? No. Which is in the lowest supply? The anion. So we add another anion and we get +6 -6. Does that equal 0? Yes. So this takes 1 chromium, but it takes 3 sulfates. Now, when you're dealing with a polyatomic and it takes more than 1, if you are required more than 1 polyatomic ion, place the ion in parentheses. With the quantity. As a subscript to the right of the parentheses. So we would open a parentheses, we would place our polyatomic ion in there, and then we would close the parentheses with the quantity needed as a subscript to the right. Okay. This by name is chromium 6 sulfate. Now, I'm going to go back and if you look at where I said we're going to start today, I said the simplest way is to cross, drop, and simplify. I want to illustrate cross, drop, and simplify on these two. that we just did so that you can understand what cross drop simplify means. Let's take the sodium one, or sodium. And the oxide. You cannot see it written in this format, but there is a 1 here. You are going to take the numerical value from the sodium. You're going to cross and drop it on the opposite atom. You're going to take the numerical value of the oxygen and you're going to cross and drop it on the other atom. So on our sodium, we dropped a 2. On our oxygen, we dropped a 1. Now to simplify. In this particular case, the only thing we can do is to divide both by 1, so it's already in its simplest form, Na2O. If you can divide by anything other than 1, you have to do so. Let's look at our chromium 6 sulfate. You're going to take the number associated with the chromium and you're going to drop it on the opposite ion. You're going to take the number on the sulfate and drop it on the opposite ion. Now, in this particular case, we would have dropped a 2 onto the chromium and onto our sulfate, we would have dropped a 6. Both of these are divisible by 2, so we must do so. And therefore, the formula is CrSO4 3. Yes. Okay, I'm glad you asked because I don't know if I ever stated it. When you're looking at an ionic compound, the formula of an ionic compound must always be in the simplest whole number ratio possible. So again, the reason we're doing this is that the formula of an ionic compound must be in the smallest whole number ratio possible. So now the reason we cross and drop is just that's a much simpler way than writing out the ions themselves. But the reason we simplify is because an ionic compound's formula must be in the smallest whole number ratio possible. Questions about the formation of the formula and the name of an ionic compound as far as general concept. So the key points that have been brought forth is number one, we have been developing the formula of an ionic compound from the ions. The compound has to be charge neutral, meaning all of the positive has to be counteracted by negative, so that the compound itself has zero charge. The cation is always listed first in a formula. The simplest way to develop a ionic formula is to cross, drop, and simplify, where you take the numerical value on the charge, you cross and drop it on the opposite ion. And then you have to simplify, because ionic compounds must be in the smallest whole number ratio possible for their formulas. And we've talked about developing the names of ionic compounds from ions. Basically, in this particular case, you just combine the name of the cation with the name of the anion. The cation is always listed first. So what I've done is I started out by illustrating how we're getting to charge neutral. And the name of the compound. But then I showed you the simpler method, which was the cross, drop, and simplify. Questions? Okay. You may have a couple of those on the test, but you're not going to have many of those on the test. What you're more likely going to have on the test, as I'm going to tell you, you have, aluminum phosphate. Give me the formula. Aluminum is element number 13. What is aluminum's charge? It's a +3. Phosphate. I see the word 8. Well, it comes from phosphorus. Phosphorus is in period 3 through 7. So what does that mean for the number of oxygens? There are 4 oxygens. Phosphorus is in period 3 through 7. So what does that mean for the charge on phosphate? It's in group 15. It's a -3. Why? It's in group 15, and it's going to be the same as the charge on the anion of phosphide. Now so that's the translate. Now we cross, drop, and simplify. So on aluminum, we're dropping a 3. On phosphate, we dropped a 3. Both of these are divisible by 3, so we do so. And so the formula is simply AlPO4. Now, most of the time, if you have just one polyatomic ion, it is not in parentheses. So typically you would write it as simply AlPO4. Let's look at copper 2. Chloride. What is the charge on the copper? 2. How did you know that it was a 2? Because the Roman numeral gave it to you. Why was the Roman numeral necessary? Because you don't automatically know the charge, so I had to tell you what the charge was. Chloride, what does IDE tell me? It's an anion of an element or a polyatomic? An element. IDE tells you most of the time it's an anion of an element. So it's the anion of chlorine. And what would chlorine's charge as an anion be? -1. And how did you know that? I think I heard it. It's in group 17. Then we cross, drop, and simplify. So on our copper, we are placing a 1, and on our chlorine, we placed a 2. That is the formula for copper 2 chloride. Let's go with lead 2 nitrate. You have lead, which is Pb, element number 82. What charge does it have? A 2. How did we know it was a 2? Because of the Roman numeral 2. Nitrate, I see the word letters ATE. So what type of anion am I dealing with? Elemental or polyatomic? Polyatomic. Nitrogen is in group 2, period 2. So how many oxygens is this H gonna have? 3. Now, unlike period 3 through 7, the charge doesn't match the element's charge. You have to know these. And nitrate has a -1 charge. So we're going to cross, drop, and simplify. So on our lead, we're dropping a 1. On our nitrate, we drop a 2 because I'm dropping a number greater than 1 on a polyatomic. What do I do to the polyatomic? It goes in parentheses with the number dropped outside. What now? Okay, that's a great question. The question was, do parentheses only go around if it's a polyatomic? And the answer is yes. Only if you need more than 1 polyatomic do you use parentheses. Okay. Barium arsenate. What is the cation? Cation's always listed first. So it's barium. What charge does it have? +2 or 2+? How did you know that? It's in group 2. Yes, I'm going to continue asking, how do you know this? How do you know this? Because that is half the battle. Arsenate. Oh, I see 8. What does that mean? Polyatomic of arsenic. So arsenic is AS. AS is in period 4. So how many oxygens is it going to have? 4. And it is in group 15. Does that matter when you get to this group period? Yes. So what's its charge? 3 minus. And we're going to cross, drop, and simplify. So on our barium, we're going to place a 3. On our arsenate, we have to place a 2. So we're going to put the arsenate in parentheses with the quantity as a subscript to the right. Yes, I know you're almost out of juice. Okay. To me, going from the name to the formula, well, it has its own challenges because you have to memorize the formulas. Now, I've tried to give you so many different ways to help you memorize those formulas. But it still comes down to memory work. Going from the formula to the name is more challenging. When you get into this, the first question you need to ask yourself is, does the metal have a constant charge? Meaning, is it group 1? Is it group 2? Is it silver, cadmium, zinc, aluminum, gallium, or indium? If it's one of those, then yes. So you're going to name the metal. And name the anion. It is when we say no that it is challenging. Because if I say no, what does that mean? Huh? A Roman numeral is necessary. So, calculating the Roman numeral. It will be the number of cations times some variable like y. I'm just using y. It's just a variable. I could have put z, I could have put a, I could have put anything. Y is just a variable so that I can distinguish it from the time sign. Plus the number of anions times the anion charge. And that is going to be set equal to 0. And then solve for y. So let's see this in action. Okay. We know from the formula there is one iron. And you're going to give it the variable y. We know there are 3 chlorines. What charge does chlorine have? It's element 17. -1. And how did we know it had a -1 charge? Because it's in group 17. Okay. So we have 1 times y plus 3 chlorines times a -1, and that is equal to 0. Y plus technically a -3 is equal to 0, or in other words, y minus 3 equals 0. Y equals 3. So this compound, Y again is telling you the Roman numeral. So this is iron with a Roman numeral of 3, and then chloride. Now, folks, if you don't know the charge on your anions, you're not going to be able to do this math. If you don't know the charge on your anions, you're not going to be able to do the math. Okay, we go back to the questions that I posed up here. Does the metal have a constant charge? Does magnesium always have the same charge? Yes, it's always what? +2. Why? Because it's in group 2. If I can't drive anything else home, I'm going to drive certain things home. Because it's in group 2 and it's always a +2, we simply name the cation, magnesium, and we name the anion. What is SO4? Sulfate. So this is magnesium sulfate. We are going to do nothing but these last 2 bullet points on Wednesday. You are going to be sick of them. But at the same time, I know how hard this next test is going to be, and this drives students up a lot. So I'm going to try and drive it home before we get to the exam. So we will work on this on Wednesday.